Our next presentation is Tim Evans with Cisco, presenting on monitoring BGP using open source OpenBMP and Apache Kafka.
Hi, great, thanks. So yeah, I'm going to talk about monitoring BGP and route links using OpenBMP and Apache Kafka. So the first challenge is to collect the BGP data, and traditionally to collect the BGP data, we could use VTY access. The problem with VTY is that it is not real-time, it's poll-based. You have to make requests to the router and issue commands in order to get the data. Typically, the requests that you do to the router with the show commands are large output responses, so the results can be in 100+ megs of data, which can impact the router's management plane, so it's not typically desirable. It can also be slow because you have to make requests to the router, but in addition to that, the router processes the request in a synchronous fashion, so it doesn't do it in asynchronous. So you have to do a request, make the wait for the response, and then issue another request, wait for the response, to which can cause a backlog. If you're planning to access all your routers, it ends up becoming slow. Because of the access requirements for making the connection, it typically also adds to the slow connection time, as well as requires the management system that wants to collect the data to maintain credentials, as well as the inventory information for the devices that it's going to connect to. So it becomes harder to maintain the inventory database in order to even collect the data to begin with. And the maintainability is pretty complex because even with the BGP, or even with the output from the data, it can vary by platform and version. And when it varies, even if you had Yang or you had other data representations of the information, it still is going to be revision-based. So you still find yourselves having to maintain some type of cache for this router, this platform has this capability. And you have to end up maintaining that and updating it every once in a while. So another method to collect the BGP data is to use packet capture. And if you packet capture, you will get the pre-rib information, you'll get all the information for the BGP peers, and you'll get the BGP updates as they are. But it doesn't really work over encrypted transports, and it doesn't work unless you have a specific architecture to support the packet capturing. So if it's multi-hop or IBGP and the session traverses multiple interfaces, the collector has to reassemble those potentially multiple packet capturing feeds in order to determine if determine where the packets, the sequence of the data. And potentially it could have to do reassembly as well, which makes the collector more complex and harder to implement. Even with the packet capture, the collector doesn't know what the router is doing with the peering, so it doesn't have any visibility to the states of the peer. It doesn't know what the peer is doing as far as post-policy and pre-policy. So it can only make assumptions, and because of that, the packet capture typically requires that the collector has to parse the open messages and has to maintain the monitoring of the BGP keep alives, which is just more work for the collector and makes it kind of a burden. And it can also be a security concern because the fact that you're packet capturing, it can be a problem if you're doing this in a live, always on, always monitoring fashion. And you might have to audit that in order to make sure that you're not capturing data that you're not supposed to be capturing to begin with. So it just makes it a little bit more difficult. BGP peering is probably the most popular way to monitor BGP, but when you monitor via BGP peers, you are only going to get the interpreted view of